Ooh, thank you for that. So, are we live yet? Go. So, welcome everyone on the camera as well. But also you guys here. It's so good to be back in person. Like I love Stockholm and I love being in person at events, and it's so good to be back here. Feels reassuring. This session is going to be called, or is called, "A Match Made in the Cloud, Not in the Heaven." In the cloud, however, Azure Container Apps plus Dapr. So, Azure Container Apps, to an extent, was already covered by Jakob yesterday. I'm not going to have a lot of emphasis on this one. I think there's a very interesting thing, a piece of technology that almost goes under the radar for many, which is called Dapr. And no, I did not misspell this one. There is another Dapr core technology called, or spelled Dapper, which is almost like an object relational mapper of things. Fantastic tech, but that's different. Today we're going to talk about DAPR, which is distributed application runtime. And I also like to travel a lot. And recently I was in Stuttgart. In Stuttgart, there are two fantastic museums I absolutely love. One of them is the Porsche Museum because, well, Porsche or Porsche, as the Americans would say. And the other one is the Mercedes Museum because Mercedes. But jokes aside, I find that the Mercedes Museum is one of the best ones because not only does it show and highlight the brand history, but it also shows you how automobiles ended up being built throughout the years, over 150, 40 years or something like that. And it starts off, it's a five-story, five-level museum, and it's in the shape of a spiral. So you start at the top, and then you go down on the spiral, and you look through the history effectively, and you watch how automobiles were being built, but also how civil wars and the world wars and everything else in effectively happening throughout these hundred something years impacted the way cars were built and how we ended up implementing ABS systems and seat belts and everything else, right? Because the mind shift of mankind shifted. And it's interesting because when you start, you have this horse. It's the statue of a horse. And supposedly, there's a quote which is supposedly coming from Emperor Wilhelm II. It's only attributed to him, which effectively says something along the lines of, "I do believe in the horse. The automobile is no more than a transitory phenomena." I do believe that he was wrong. And here's the thing. So when you start up with that museum, this is the first thing you see. This is believed to be the first automobile ever. In the back there, you'll see what is referred to as the grandfather's clock because it looks like one of those very old pendulum clocks. That was the very first engine installed in an automobile, and this is the very first automobile ever. What you see here is the tank, and the tank used some combustion of things that you would actually buy from a pharmacy, from an apotheke, as you call it, right? This is the steering wheel. It's just a lever. To me, it looks like something completely different, not a steering wheel. But it is attributed to be as the first automobile ever. And I do appreciate it because as you go through these automobiles, iterations, because I call them iterations, you see this thing as the second generation automobile. In my opinion, it's missing a horse. Then you go for the next generation. And this is kind of the third generation automobile that you learn about in that museum, in the Mercedes Museum. And it's interesting because now you see that everybody who was involved, like literally inside physically in the automobile, right, was involved in the movement process. The ones in the front were not passengers, but they were responsible for braking. The ones in the back, yes, it looks like an amusement park, doesn't it? It is not an amusement park though. It is an automobile, a genuine automobile whatsoever. And this is the real thing, by the way. Like this is 100 something years old. And the passengers in the back, they were responsible for the entire movement process, I guess. And it was already overly complex because of distribution. So nobody had steering, right? They had to put it on tracks. It's still an automobile. Isn't that crazy? Then they said, okay, we're going to go back to the roots. We're going to do monolithical whatever cars. And they came up with this. where the chauffeur was in the front, supposedly maneuvering that steering, which still looks like a lever, not a steering wheel. And again, in my opinion, it's missing not one horse, but two horses. I don't know, just me. And then they started to figure out how to create an automobile. So this is what, the fifth generation? It's called the vis-a-vis car. In my opinion, it's the worst one ever because the steering itself happens from the back seat. I mean, can we imagine like trying to drive like this because you can see nothing because of the passengers you're driving around? It's crazy. But it was social, right? It was a statement. And it drove somewhere around 7 kilometers per hour. And this was 1896, and this is the fourth or fifth generation automobile they've built, Daimler and Maybach, because they were the big heads behind it. Then they figured it out. They put the passengers in the front, they put them on the back seat, and they traveled with their back. It's crazy. But where am I getting this? So after several years, they ended up actually having a proper automobile-like looking thing, right? It finally had a steering wheel of sorts, but we were getting there. Now, 2 years ago, I came across this picture. This picture was taken in the early 1900s. Probably 1903 is the closest year I could get to. And this picture shows you the Fifth Avenue in New York City. One thing you can tell is that back in those days, New York City's Fifth Avenue was as crowded as it is today. On the other thing, something that the picture does not tell you, it was that it was probably very smelly because there was a lot of horses. I was just about to say something else. Um, but the question is, cars already existed. Where is the automobile in the picture, right? Well, there is one. Did you find it yet? Some people might have. It's right there. But it's one car, and cars existed. Now let's fast forward no more than 10 years. 1913, Fifth Avenue, New York City. Exactly the same spot. Better looking picture, but something is totally different. So we have had for several decades cars, even the crazy vis-a-vis car, right? And yet nobody would actually drive them before something happened. Does anyone know what happened between these 10-ish years? Go ahead. They became affordable, and the only reason for why they became affordable was because of an individual called Henry Ford, which I trust that most of you have heard of. Henry Ford didn't necessarily build the best looking car. He didn't necessarily build the best, most performant car. He did something else. Does anyone know? Mass production. The way he envisioned mass production was that rather than having experts, one working on maybe the steering side, the braking side, the wheel side, or whatever, they had individuals working almost like on a conveyor belt, but on a machinery and manufacturing belt, where they would never lose their spot. They would never leave their spots, and they would always do the same thing over and over and over again. 100 years later, we're still doing that, but with robots. So I might say that Henry Ford came up with a revolutionary idea, not for the car itself, but for the process of building the car. And 100 years later, we're still doing that thing, and we're doing it damn right. And if you look at these cars, interestingly, even the cars themselves, 100 years later, they kind of work and look the same way as they did 100 years back. We don't have the chauffeur in the back seat because that would be crazy, right? He got it right. We don't have the chauffeur outside of the car because that would have been crazy as well. Most of the cars, except for some, would have their engine in the front. And there's a bunch of things that we actually do the same. One thing is for certain, we drive the same way that we did 100 years ago. So what is so special, and why am I even talking about this? Oh, by the way, can you picture where the horse is at? There's one carriage pulled by a horse, and that's it. In less than 10 years. How crazy is that? In my opinion, that's what's revolutionary about a single idea. The single idea of building the cars. So what does that have to do with applications that we're building in software, with the cloud, with Dapr, with Azure Container Apps? Well, hear me out. I've been working as a software developer for more than 2 decades now. I've developed software for mobile apps, for web apps, for desktop apps, for IoT before it was even called IoT, embedded applications, robotics. I've done them all, probably, right? I did not develop in all of the programming languages, but I did work with some, and I love it. But what's different is that today I'm doing less software development not by choice, but by enforcement. And we're going to get to that. As a soft developer today, I have to know ARM, I have to know Bicep, I have to know Ansible, I have to know GitHub Actions and Azure DevOps pipelines and this and that. And don't even get me started on Kubernetes. Those are things that they force you to learn. And I'm going to get to that. But there's this one word, microservices, which everybody has heard of. It's not a new word. But interestingly, even when it was a new word, it was not a new concept. I've heard of SOA iterations, I've heard of microservices, and every time I read Sam Newman's book, I'm enlightened. Like, yes, this is the way to do apps. But then I realized that the real world and what Sam Newman talks about when he talks about microservices, they don't necessarily collide. Don't get me wrong. I'm not here to contradict Sam Newman. He's a fantastic individual. He does everything. He mentions everything correctly. But the concept that every organization is going to have different teams and is going to work within their own bounded context and they're going to develop single responsibility applications and projects within a big ass app, that's not entirely correct in my opinion. And the reason I'm saying that is that not every organization has 100 plus developers or 1,000 plus developers. There are mid-sized organizations. There are small-sized organizations. And the way it usually works in a team, which is, as you know, usually comprised of 7 individuals or at least any number of team members which can share a pizza, right? Because that's, according to, well, a lot of theory, the good-sized team, is that you're going to work within an iteration, within a sprint on one feature. The next iteration, you're going to work on something else. So you might be an expert today on your payment system and your payment aggregation, but next week, you're not going to work on that feature anymore. You're going to work on the recommendation engine on an e-commerce application. Next week, they're going to ask you to create your product catalog on a different technology. And the problem with this is that inception or that idea rather, where you're going to talk to experts in other bounded contexts, but you're going to share some data, only some data with them, is partially correct because that other team might actually be yourself, right? So you end up having a lot of responsibilities in terms of the projects that you write, and then you effectively check out at some point because you now got to work on something else. And the problem of having many different individual isolated components is the integration in between them. Because the moment you start no longer caring about the payment aggregation system, 5 sprints later, you figure, hey, there are 10 NuGet packages which I need to update. And by the way, there's a new version of .NET. And by the way, there's a new version of something else. So now I got to go back. And you redo those same operations, not one time because you have one big monolithic project, but 10 times, 50 times, 90 times, 100 something times. The biggest microservices project I worked with was 120 different projects. Never possible to put up in Visual Studio. No matter how good the Visual Studio team is, they would never be able to have a single solution with all of the projects they have. So even the development process whatsoever is completely chaotic because you write something and you can never properly test it on your own machine. So how do you fix that? Well, there have been, let's start with that. There have been multiple approaches towards developing microservices the right way. But the reality, in my opinion, is that they never got it right. There is one thing, however, which is called Dapr, and this is where Dapr comes in. Dapr has been an incubation project of Microsoft. An incubation project of Microsoft, like Dapr, usually is overseen by a team which is run by Mark Russinovich, the CTO of Azure, right? Very smart individual. If you haven't heard of him, make sure that you look for his video recordings at various conferences, including Microsoft Ignite and Build, where he talks about Windows, where he talks about Azure, where he talks about the data center internals. He actually wrote the freaking Windows internals book. Back way before he was even hired by Microsoft, he was the individual to teach Windows kernel to Windows developers when he was not working at Microsoft. Very smart individual, also writes fantastic science fiction books. So his incubation team is comprised of multiple members. At some point, he took 2 individuals, Mark Fussell and Jaron Schneider, who were both responsible for a product called Service Fabric. Anyone ever heard of Service Fabric? Some of you have. Fantastic. Service Fabric is the engine which runs things such as Cosmos DB, Event Hub, Event Grid, IoT Hub, and many, many more. It's the magic which runs Azure pretty much, right? But we're not going to get there. So he took these 2 individuals with a single quest, which was, let's make sure that we develop a product or create not a product, but rather a concept, a runtime of sorts, which is going to allow people to develop applications the right way we do it at Microsoft, right? So Mark Fussell and Jaron Schneider went onto this quest. Several years later, they no longer work with Microsoft. So a lot of people come today at me and they tell me, is Dapr still going to be a thing? Because I heard that these two individuals, they're out. But here's the thing. Both of them actually founded their own company called Diagrid, which is a very successful company. Not only that, but Diagrid actually 2 weeks ago, they got a Series A funding because they're a startup of $24 million. If you're interested, look up what the Series A funding for Docker was, and you'd be amazed. The Docker actually had a Series A funding which was less than Diagrid got for the product and the idea that they're coming up with. And they're the main maintainers of Dapr. Dapr is still highly supported and developed, and Microsoft is heavily involved in the Dapr development process whatsoever. Not only that, but Diagrid's board member include individuals even like Joe Betta. Anyone ever heard of Joe Betta? What about Brandon Burns? What about Craig McCluskey? Okay, let's repeat this. Anyone ever heard of Kubernetes? Yeah? Kubernetes had 3 original authors. Brandon Burns no longer works at Google. He's the heads behind containers at Microsoft, right? Anything which has to do with containers, Windows containers, Kubernetes, AKS, Azure Container Apps, Azure Container Instances, Azure whatever else containers, Brandon Burns. Joe Betta and Craig McCluskey, they both work for VMware unless they've shifted roles or whatnot, and they're responsible for VM Cloud. So these individuals, they were the original authors of Kubernetes. Joe Betta is one of the board members for Dapr. Just picture that. Is Dapr going to disappear from the market anytime soon? I doubt it. So what Dapr effectively is here to say is that they're going to come up, or they actually came up already, with the so-called distributed application runtime. And this right here is something that I took from Mark Russinovich, and that's the literal definition of what Dapr is. And it's a very well set of very well picked, hand-picked words. A portable, because you can run it anywhere, any cloud, on-prem, doesn't really matter. Linux, Windows, honestly doesn't matter. Serverless, well, we all know what serverless really means. Event-driven runtime, just like Azure Functions. I love your T-shirt, by the way. That makes developing resilient, stateless, and stateful microservices easy. Every single noun, every single adjective that you see there is very well handpicked because this is literally what Dapr is. So the whole idea of Dapr is that it comes with this concept of various building blocks. And each one of these is effectively responsible for one of the theories about microservices, except for maybe the first one. The theory of microservices at least says that you should never have direct invocation among your services, because if you end up doing things like the HTTP chaining, where one microservice directly calls the other microservice, you're going to create a long HTTP chain. So if one thing fails in the chain, everything fails, right? It's effectively a castle of cards. You don't want that. But there are exceptions when you need that, like the microservices concept of backend for frontend. Anyone ever heard of that? So BFFs, not best friends forever, stands for backends for frontends. Effectively means that you're going to have one microservice, which is even potentially going to cache information, which is going to be pulled from other microservices. It aggregates all of the information together to create front ends, like user interfaces on a web page, on a mobile app, whatever, so that when you open up your Amazon.com, rather than calling your shopping cart microservice and calling your product microservice and the recommendation engine microservice, which are all APIs, you call a single API, which is all of the information aggregated for you, right? Makes sense. That is a scenario where service-to-service invocation is completely useful. Statement management, publish and subscribe, pub sub effectively, resource bindings, everything else are components which Dapr can offer. But here's the cool thing about Dapr. It's unopinionated, meaning that you can use all of them, you can use one of them, you can use them mixing them up with Envoy and Istio if you want to do things, or Linkerd if you want to do things such as service meshes and whatnot. You can use them all together. And the way Dapr is designed to work, see this logo? Looks like a butler to me, right? Anyone ever saw a movie called Hotel Budapest? Some of you have, right? Hotel Budapest, for those of you who haven't seen the movie, I'm not going to give you any spoilers, but the whole idea is that there is a network of concierge people around various hotels around the world. So if you need something done, or if you need something, to retrieve something, they're going to get it for you. And it's almost a shady network of concierge people around the world, because if you need a pizza, they're going to deliver it to you. If you need something stolen from somebody else, they're going to deliver it for you, right? It's a very fun movie. I totally recommend it, but Dapr works exactly the same way. For instance, service-to-service invocation. If you have a service which needs to talk to another service, You never have to know an IP address. You never have to know a fully qualified domain name. You never have to know anything. You just tell your concierge, your Dapr, hey, can you pass over this payload? And by the way, I need the response. And Dapr is going to figure out, just like a service mesh, how to route that request to the right place. It's going to get you the response back. And you know what Linus Torvalds used to say? Enough talking, show me the code. And I fully agree. So the first thing I'll do here is to close down StreamYard. I'm kidding. But I am literally missing something, which is important for me. So the first thing I'll do, this is tiny. Even my cursor is super tiny. This is better, right? I'm kidding you guys. We can go even further. There we go. So the first thing I'll do here is that, oh yeah, totally. Is that well? Good enough? Okay, yeah is not yeah. There we go. So the first thing I'll do in this folder is I have several. Let me actually open up code. I think that's way better, right? Jesus Christ, what's going on here? So in this folder, I have a couple of projects. One is called the checkout project. The other one is an order processor. As you might imagine, because this is a no-brainer, this is going to simulate kind of an e-commerce scenario environment, right? There's a solution file, but because I'm on a Mac, that's completely pointless. I cannot use it whatsoever. I'm using VS Code instead. And in this project, what I'm about to do is that I will actually decide to, first and foremost, open up the order processor. But let's look at the code for a second. It looks like it was already compiled, but I'm going to recompile it nonetheless. So here I have one of those minimal API approaches where I'm just building a host builder effectively for my web app. And then the most important part is right here, where I'm saying any request that ever comes into the orders endpoint is going to be mapped. And as long as I'm using the HTTP verb post, I will just do my super cool business logic, which is just say that I've received an order, right? Let's forget about that part. But the whole idea is that I'm mapping to orders. But just like any API is going to accept incoming messages, right? Okay, let's go back real quick over here. And let's imagine that I want to run this application. It's going to be a freaking cool app. So let me clean it first. And then I'm going to say that I will restore. Should there be any NuGet packages? But you know what? Let me also show you one interesting thing, namely the fact that if I look into my CS proj, this is a typical CS proj, no special NuGet packages. This just swashbuckle. Does anyone know what swashbuckle is? Come on, go ahead. Yes, that's right. It's for Swagger, for the reference of the recording. And then I'm going to run .NET build. Alrighty. So this being a .NET application, how would you normally run it? .NET run. But here's the thing. I want to Daprize this application. And this is the reason for why I love the fact that they call their product Dapr. Because in English, do you know what Daprize means? Dapper as an adjective, what does dapper mean? Good looking, fancy looking. Like we're going to make our application fancy. We're going to Dapperize the application. What about that? So rather than running .NET run, I'm going to fancy up the app. And I'm going to say Dapr run .NET run. But there's going to be some parameters required. So the parameters I'm going to provide here, first and foremost, I will say that the application has a port where it listens on 7001, for instance. And then I will specify that the application will have a unique identifier for itself. So this being the order processor application, well, let's call it order processor. And then I will also specify that this application is communicating over HTTP, because remember, Dapr does both HTTP and gRPC for that matter. Go ahead. Oh, thank you for that. Thank you, sir. That's why you're here. And then additionally, because I want Dapr to accept incoming messages for this particular application, I will tell Dapr that I want Dapr to effectively act as a proxy of sorts, where any request that comes over, say, 3501 is going to be called further or forwarded further to the application instance. And then I'm just going to use two hyphens to separate the Dapr run command and its parameters to the actual thing I want to run. And this effectively should already tell you, I know that this is over here at the bottom corner, right, bottom right corner. This should tell you that I can actually run anything. An exe, a service, a Python app, doesn't really matter. I can Dapprize anything. So I'm going to hit enter on this one. Ooh, we couldn't find a project to run. What about that? Let's close this guy. Control C. Come on, do your thing. Updating metadata for the command. Oh, you know what's going on? I do. I'm going to fix it. There's a button which says reboot. I'm kidding you guys. I'm not going to reboot. Just pull the cord. It's not yet. It is not yet fixed. But you know what? This proves yet again that whenever you have a live demo with a audience online, you first must mandatorily sacrifice the production virtual machine in Azure in favor of the demo gods. And then you're good. Do you have like a wildfire for the virtual machines in production? Oh, come on, please stop. Okay, there we go. We're going to clear everything and do it one more time. Because when it doesn't work the first time, if you do it one more time, it's going to run, right? It almost ran. Which folder am I in right now? Yeah. Okay, so except for that part, which had me in the wrong folder, now I'm actually running the project correctly. And what you see here is partially something that you've seen in the past. Everything which is on the bluish line, because here on this particular display it's light blue, is effectively .NET, application code, application logs that you have seen when you run .NET Run. Everything else is Dapr, and that's effectively a Dapr log coming in. So my application right now is listening on 1701, and you remember from the application port per meter that I provided Dapr that this is where I've hooked up my application at. And then it says the application is started. I can Control C to shut down, yada yada yada, and everything is nice and cool. So here's what's going on. I will now decide to actually open up a new tab in this window here. And I will head over to the checkout project instead. Let's look at this project as well. And inside, you know what, I'm not going to use this window, but this one instead. Inside this project, you'll see the very complex business logic, which is going to generate some orders and effectively iterating from 1 up to 10, because I'm not the proper developer. I started from 1. I will just create an order object, and then I'm going to send this over to the orders endpoint. But here's the cool thing about this. When you see this base URL, normally in a typical application, you expect that you would hook up to that one instance of the project running. And if that instance is not running, then this application, which has dependency on that, would fail. Right? In microservices, that's completely unacceptable. Dapr has that figured out because the base URL actually is my Dapr application rather than the application itself. So I'm pulling the environment variable from an environment variable, the port that Dapr is listening on, and I'm telling Dapr, hey, can you please send this information? But because it's a synchronous call, I don't have to ensure that there's a dependency running because Dapr will do that for me. So I can just wait until that dependency is up and running and my application would never fail. Not only that, but Dapr could even tell me if I want to configure a timeout that, hey, sir, we're sorry, but your application has fallen. And I can even wrap that and effectively generate a specialized HTTP response for this particular checkout checkout application. And then I have another complex logic here with a from seconds 1. So I'm going to delay every single request I'm sending because I want to show you guys, whilst I will run this application, that there is a complete synchronicity between the two calls. So let's head back to the terminal window. And as always, .NET restore, .NET build, and then I'm going to .NET run this, but sure enough, I will not because I want to Dapprize this. So the way you Dapprize it correctly is that you say Dapr run, application identifier checkout, and then we're going to say application protocol, HTTP. Did I misspell that again? No, I have not. And then Dapr HTTP port 3500. Now, the one thing thank you, sir. The one thing that you will be able to tell here is that I have not specified an application port, and the reason for that behind it is that I don't need this application to receive incoming messages. I just generate messages, and then hence I will only let Dapr communicate with the other microservice, right? So if I hit enter on this guy, fingers crossed, there we go. So the first order was generated and sent over to the other app. And again, the cool thing is that I do not save IP addresses. I do not use fully qualified domain names. Heck, I don't even use DNS for this one. It's a service mesh implementation, so you don't need to worry about all of those crazy protocols. You know, when something goes down on the internet, it's DNS. That's an IT joke, but it usually literally is, especially in the last days, DNS. So this thing finished its job. The microservice was killed, but the other thing is still working. And again, the cool thing is I could stop this guy, and this guy would not break because Dapr would still be waiting for it, right, to work. So even dependency invocation is something that actually works pretty well. Cool. Any questions so far? So no NuGet packages, just plain old HTTP. We don't need to do any service discovery. Dapr fixes it all. One thing I did not tell you, which was a bit hidden, is that in my implementation here, I have a single instance Dapr. That's literally what they call it. So I have Dapr running on my computer, and I have a single concierge effectively knowing everybody around. So I could use effectively that CLI that Dapr has to offer, DAPR, and do something like list, and it will tell me this is a table. Imagine that this would be a table. It tells me every single instance which is running, where they're listening, and so on and so forth, right? So this is a very nice way to shim away what other microservices would expose because Dapr fixes that. But of course, other products and other technologies, Linkerd, Istio, Envoy, they also do this. But again, I'm a developer. I just want to know C#. I don't want to know all of the other technologies. But as we go further with this, we'll actually realize at some point that there is another. I'm going to close this guy down, hopefully. This resolution here is killing me. But zooming in a lot. There we go. Over here, I'm in a completely different application scenario now. Let me open up code, and I will show you what this is all about. So in this application demo, I actually have a single order checkout process. And what I'm trying to highlight here with Dapr is that I could, for instance, have a more complex business logic where I'm generating these orders, and rather than just sending a number, an index, I'm going to save the order information, retrieve the order information, and delete the order information from a supposed data store, which I'm going to invoke using this client object and by using a method called save status sync. And similarly, there's a get status sync and there's a delete status sync. This client object, which you have never seen before, is actually a Dapr client, which is built by a factory from the Dapr client builder. Now, here's a question for you. Obviously, because I have this specialized object here, I have decided to include a NuGet package, but I could choose not to use this and rely on the plain old HTTP client that we all love. Now, the question is, where do I actually store this data? I know it's in the data store, but is it like on my machine? Is it in Azure, in Cosmos DB, in storage accounts, in AWS's DynamoDB, anywhere else? What do you guess? What do you think? Go ahead. Maybe somewhere in Azure. What do others think? In memory, in Redis. Honestly, it could be anywhere, and that's the beautiful thing with it. Dapr is all about abstraction. So remember when I told you that 20 years ago when I wrote code, it was all about C++ and later C#, and that was it? And then NuGet packages came along, and now I have a lot of libraries and it put things together like Legos. Well, today, it's not just that. It's infrastructure as code, it's Ansible, it's ARM, it's Terraform, it's a bunch of YAML that you have to learn about Kubernetes, and God knows what else, right? And the cool thing here is that I'm just saying, save some data, get me some data, remove some data from me, and then let me prove that this actually works. Again, I did not yet sacrifice this production VMs, so I might be actually on an edge here, but we're going to try it nonetheless. So what I will say is that I'll do a .NET restore, .NET build. I'm literally doing .NET restore and .NET build because 4 or 5 years ago, I was on a demo on a live stage, and there was one application which just, for whatever good reason, did not want to start. And I was even rebooting my machine at some point, and it was just missing this. .NET was .NET Core back then was quite good view. Anyways, I'm gonna run this application again. I will not say .NET run, but instead Dapr run, right? Typical approach. Application ID can be order processor again, and then further on I will say that I will run .NET run, but a special new parameter components path. Components path. And over here, I'm going to say dot dot wag dot dot wag dot dot wag. I love how that sounds. Components. So this is a special parameter where the Dapr CLI is going to look into that folder. It's going to pull all of the YAML files. It's going to try to understand that manifest, and it's going to start working with it. And I will show you that those manifests in a second. But right now, what you see is that an order was generated. It was saved, retrieved, and then deleted. Again, saved, retrieved, and deleted. And it keeps on doing this for 10 times with a delay of 5 seconds between every single set. So the question here was, where is that data stored? If we actually look into that folder, which is .wag, .wag, .wag components, you're going to see that there's a state store YAML file. If we look back into the code, I want you guys to pay close attention to line 13. It says that my data store is going to be called state store. That name is completely random. I could simply say here AlexDB because you have MariaDB. Why not have AlexDB, right? I'm going to make an AlexDB from this point onward. So if I actually look into that YAML file, components, and then state store, you actually see here that there's a name, this part right here, which has to match the name of the database, quote unquote, that I'm going to work with. And the cool thing about this abstraction is that I never have to write any boilerplate code specific to SQL Server, or ADO.NET, Entity Framework, Redis, and anything else. So if anyone ever comes in and tells into your office, hey guys, we're going to move over to AWS and make sure that you make everything cloud native tomorrow, right, never going to happen. Not with Dapr though. If you really want to test things out, or leave it to your operational individuals to figure out how to use one technology versus the other, and compare and contrast the performance you may potentially get from DynamoDB versus Cosmos DB or whatever else, you could just use this because these are just pluggable components that you literally plug in using a simple YAML file, a fancy JSON at the end of the day. And everything you see here is effectively under the specs. The fact that we're going to use state, so this is something that Dapr understands, and separated by the dot, we're going to specify that this is the Redis technology. Do you know, or can you picture what it would take me to change this application to use Cosmos DB instead? That's spot on. Thank you, sir. Isn't this cool? So the answer was just change the type. And sure enough, if I go over here and say .azure, .cosmos DB, and then specify a couple of parameters, or just one parameter actually for the connection string, I'm done. Go ahead. Dude, you need a prize. Isn't that cool? I mean, seriously. You want to change this to AWS because you want to see how AWS actually works? We probably don't, but still, if we would, on a Friday afternoon, the whole idea of an abstraction takes a whole different perspective now. That's the cool part with it. And it's not only about the abstraction, but here's the thing. I've been using Azure literally ever since Azure was a small baby, 2010. Prior to that, it was called Red Dog. Back then, Azure was called Windows Azure, just FYI, which was fun. For reference, back in those days, I had Windows 8 installed on my machines, and my friends would usually come up to me very upset about Windows 8 because their start button was taken away from them. So they were asking me, hey, I hear you work with this new Azure thing, with this new Windows thing. Can you please get Windows Azure installed on my computer? And I was like, yeah, let's have a conversation about Windows Azure because you're not getting it. Nobody understood the cloud back then. Don't get me wrong. Some people still don't. But that's a whole different conversation that we can have. Anyway, the idea back then was that if you wanted to implement the technology, say Service Bus, because we have a Service Bus PM here, there were like these 13 lines of magic code that you had to write to make sure that you use multi-threading, that you use the same client, that you reuse the client in the factory, that you use batches, that you send things in batches and then you use whatever else, and you use TCP communication. There were like 13 lines of magical code. If written, then the service bus client implementation in your C# code was just blazingly fast. Like you could literally increase the temperature of your network cable. You literally use the entire bandwidth of your network card. But if you go with your typical Microsoft Learn materials, with the tutorials, with the quick starts, you'd get very poor performance out of it because it was too complex to understand for a quick start. The problem was that everybody, almost everybody, would just take those quick starts, would have them implemented, and I'm not necessarily saying service bus, literally any technology, and they would just go with that, right? So if we take a couple of steps back, going back to these abstractions, the cool thing with these abstractions, with these components, is that they're not written by the Dapr team. They're written by the community. They're written by Microsoft. They're written by the AWS, and they make sure that the best kind of performant, optimized, fully optimized application code is written in the component so that whenever you say save this data, you're going to do a point read operation, for instance, in Cosmos DB, which is going to be the most performant operation possible without you having to learn a yet new SDK, yet new client. And let's go one step further. Imagine going back to the microservice conversation. Imagine that you have written your payment aggregation service or payment whatever gateway service, right? And now you leave that microservice for the next 5 months. When you get back to it, you're going to learn that, hey, you know what? That .NET Core 3.1 version that you designed this into, it's deprecated. Now you got to use .NET 6. Oh, but wait, you got to change your code because .NET 6 doesn't run the same way .NET Core 3.1 does. And by the way, we're going to treat strings differently because they're not going to be nullable nowadays, right? And then you learn that whatever NuGet packages that you were responsible for, or dependent upon, like Newtonsoft or whatever else, has 10 new versions. So you got to upgrade those. And something which seemed trivial, like doing one single upgrade for a single freaking NuGet package, takes you two sprints now to work on. This whole idea of microservices, in my opinion, works great as long as you don't have a lot of dependencies. And regretfully, NuGet packages are the opposite of not having dependencies, right? So hear me out. If you have these abstractions and you don't have dependencies and you have fully optimized code written out of the box, you can actually write code because that's what you guys do best because you're software developers, and then just leave it, right? Check it out and work on the next big thing. And the cool thing with Dapr, in my opinion, is that the moment you start working with Dapr, you can decide to work on a brownfield application, one of those applications which is legacy, a monolithic application. If there's a new feature, as long as your app has an API and you can communicate with the API, you can just work with another small microservice communicating with API through Dapr, and then start decomposing your app. Like when you have time, when you have enough sprints, when you have enough time on your sprint effectively, start decomposing by taking features out of the monolithic application and effectively invoking it or creating it as a microservice. Now, this all sounds great for Hello Worlds, right? So I decided to think about Dapr in terms of production code. Because the reality is that even though I'm running on a single instance Dapr installation here, the production code, you wouldn't run it as such. You'd use the so-called sidecar pattern. And everybody loves the sidecar pattern, except for the fact that it's very specific to Kubernetes. Right? Everybody heard of Kubernetes. How many people actually do Kubernetes in production today? Come on, raise your hand. Right. How many people love Kubernetes? Really? So the problem, in my opinion, with Kubernetes is that as a software developer, it takes you away from the software development side. Kubernetes initially, I kid you not, this was back in those days, it was internal conversation. I hope I'm not breaking any NDAs. But to us, the audience in that room, it was presented as a platform as a service offering. And that was complete BS, literally. Because I believe strongly that there is no more infrastructure specific technology than Kubernetes. I mean, as a software developer, the thing that you're telling me, hey, there's a platform for you to run apps, cool. But now, wait, you got to learn about pods, not only containers, because they're cool, but pods, stateful sets, replica sets, daemon sets, ingresses, services, CRDs, common custom resource definitions, and all of the freaking big number of custom resource definitions there are. And then you go learn about infrastructure and networking and virtual networks and Kubernetes networks and whatnot, right? It's so crazy. And by the time you think you got it right, and by the time you think you learned how to install Kubernetes, if that's even a thing, you learn that there's a managed product, and you're like, whew, thank God somebody's going to fix that for me, right? And they're going to maintain it. But guess what? You go with the managed Kubernetes offering, AKS, for instance, which is great. But now you learn that even that freaking upgrade process for upgrading your user node pools and your system node pools can take your application down. And believe it or not, most of the new features that ever are added to AKS are not available to existing clusters. So you got to recreate your cluster. So by the time you think that AKS was a good idea, you actually start reconsidering. Totally not. Because I want to show you something, by the way. So obviously I have a Kubernetes cluster running somewhere, and I decided I'm going to run a Dapr-based application on Kubernetes, which is going to be the next big hit. It's running on Kubernetes. So I have 5 nodes on a user node pool. I have 2 more nodes, like virtual machines on a system node pool. It has all of the fancy stuff inside, and it's a calculator application. Because why not? It's over-engineering. But it even goes further. This is a microservices-based calculator app. It's not any kind of an app. You know why? Because the division operation is written in Go. The multiplication operation is written in Python. The subtraction operation is written in Node.js. The addition operation is written in C#. The entire darn thing is designed in React.js. Because why not? Right? Remember, vis-a-vis car? Are we there yet? Right? And the thing that you see a -3 here is not a bug. I decided that it would be a great idea to see the result that I calculated 3 days ago in Copenhagen. Because why not? And that's going to be, it's a stateful app. And that's going to be stored in Azure storage accounts. But if I decide all of a sudden that I want to store this data in Cosmos DB, snap a finger, boom, 2 words I need to change. That's it. And it's going to be stored in Cosmos DB. Now, this proves a point. This proves the point that a lot of us are doing Kubernetes and we shouldn't. I'm going to be totally honest with you. After having worked with Kubernetes in production for 4 years, probably 80% of the applications I've worked with and most of those customers could do things differently, way better, in a whole different plethora of PaaS services and never have to worry about the mess that happens under the hood. Of course, this calculator application works, but it might as well work as a monolithic application. I'm not here to say that monolithic applications are bad. They've been running the world for so many years. But here is what I am saying. If you really want global distribution, if you want to take advantage of resiliency, availability, and everything else that ends with an itty at the end and is a good thing, right? Which is generally the definition of the cloud, there has to be a better way. And in my opinion, I believe strongly that that better way can be achieved not by redesigning the application itself, but the process through which we create the application. And Dapr is one of those technologies. Now, Jakob actually already mentioned about Azure Container Apps. I'm not going to repeat myself or his introduction and his presentation. If you want to rewatch it, I highly encourage you to do that because of the YouTube recording that we have available. But the idea is that all of the Dapr thing is directly integrated in Azure Container Apps. So everything you have seen in terms of Dapr can be actually leveraged by Azure Container Apps. And just as a quick pitch of Container Apps again, you can forget about all of the Kubernetes nonsense and just leverage Azure Container Apps. Let me put it differently. Anyone ever heard of Internet Information Services? The web server for Microsoft, right? Do you guys love it? If you're running on Windows Server, there's no other way, right? Well, it could be, like even Nginx, but it's yeah. Good luck on that. Hey, you have a Windows patch Tuesday thingy? Yeah. Hey, honey, I'm gonna be late for work today, for lunch today, right? We don't love it, but it's still around. You know why? Legacy applications. Can you think of a good service in Azure that would run on IaaS? Azure App Services. Azure App Services is 100% Internet Information Services under the hood, with a shim on top. Well, it used to, but it still has its IaaS things under the hood. And the cool thing with app services is it takes IaaS away from you. You never have to deal with IaaS. You never had to deal with IaaS, right? You just web deploy your application and it just runs. And under the hood, that web server farm that you're working with is a complete abstraction. You never have to worry about the infrastructure side, and it just works. Azure Container Apps treats Kubernetes the same way that app services treats IaaS. And in my opinion, there's no better pitch. Would I put my Azure Container Apps then in the future to put them in AKS? No, totally not. It's the other way around, in my opinion. If you have a greenfield application, you start with ACA, and you stick with ACA. If you already have an AKS application and you're unhappy, then you can start expanding your AKS cluster in favor of ACA. And every time you're going to do an update, you're going to look at those microservices running in ACA and you're going to be like, oh my God, those run so nice. And I have been doing this for several months now, and I can honestly say ACA is here to stay. Dapr is here to stay. And the way we write applications today, even though it is quite difficult because there is a learning curve at the beginning, is way sexier. So, with that being said, I've yes, yeah, yeah, yeah. Can you repeat now everything you've just said for the microphone? I'm kidding you. I'm gonna try paraphrasing. Effectively, what Magnus mentioned previously, and I'm 100% in agreement, is that we have seen this in the past where we have to go through the trenches effectively to get to the point where things can be at a pristine state, and we as a developer, we just do the best thing we know, which is write code and eat pizza and drink coffee, and everything else is left to be done by those who do it the best. And Azure Container Apps with Dapr is effectively, in my opinion, just that. Again, we already had a very good presentation on Azure Container Apps. I'm not going to repeat anything that was already said, but you can see the resemblance, in my opinion, with app services in terms of IaaS, as an analogy of Azure Container Apps to Kubernetes. Things such as having multiple deployment slots is revisions. Things such as having traffic in production or whatever they call it these days, where you say 20% of this traffic goes to this deployment slot, 80% goes to the other slot, is effectively called traffic splitting. You have the ability of deactivating revisions. You have the ability of hooking up your components. That plan that we talk about in app services is effectively known as an environment in Azure Container Apps. So getting started with Azure Container Apps is actually quite simple. If you've ever gotten started with app services, it was a child's play, right? Same here. As long as you have a container application, which nowadays it's super simple to containerize an application in a Docker container, for instance, then you can just get started with Azure Container Apps. It's that easy. I kid you not. Um, of course, I have a calculator application in Azure Container Apps. I have a bunch of different Album APIs and whatnot. But all my code is available on GitHub, and I highly encourage you to look into that one as well. How are we on time? I do have 90 minutes. Oh, really? Whew, whew. I know you're just joking, but that's good. I really do get 90 minutes. Really? Are you up for it? If the audience wants it, then I'm getting 90 minutes. That's great. Whew. What about that? So we can smell the fika. Yeah, I'm the only person standing between fika and you guys. Sweets and fika. Yeah, that's gonna be a very bad place to be in. I will show you a couple of applications I have here. And in case you're interested, by the way, I will actually head over to my GitHub account, which nobody will be able to tell because, well, the font. I'm kidding. It's I am Alex Mang. It's so easy. My LinkedIn is I am Alex Mang. My Twitter is I am Alex Mang. My GitHub is I am Alex Mang. If there is something I am Alex Mang, it's probably me. Especially if you see this 6-year-old picture, where I did not have hair back then either. Now, anyways, what I was about to show you is that I have um, a couple of repositories in GitHub. And you know what the cool thing about GitHub? This is something I've just learned. So I've just learned something from Stacy earlier today. I want to show you something cool as well. Here I'm on a website. I know we cannot tell, but this is Edge, right? There's a very tiny, big window bar there at the top. This is Edge. If you change the .com top level domain of the URL with .dev, I'm not going to do that because I honestly don't see anything with or without glasses. But if I actually hit the full stop key that has the same effect, I'm going to hit the full stop key, period, right? Opens up something which is known as web editor. So all of a sudden, you're still on GitHub, but now you have a web editor. You want to change anything? Rather than going into edit mode, changing stuff, clicking the green submit button, typing in a text for your GitHub comment, you can just change it from here directly and boom, it's saved into your GitHub. It's that cool. Want to change branches? You do it from here. One thing that people don't know, however, is that this is actually the smaller, younger brother of Codespaces. Anyone ever heard of Codespaces? Anyone using Codespaces? Huh? Huh? Some people are. So a lot of people have the wrong impression that Codespaces is like writing code in a browser, and who wants to do that? I mean, seriously. It's a good idea, maybe, if you're on your iPad. Like, say, sometimes I'm nerding and geeking out whilst I'm waiting at the doctor's appointment. But jokes aside, if I actually open up a terminal here, you will see I'm still in web editor, right? I'm gonna head over to terminal, which has this awkward looking swashy whatever button combination. It doesn't work. So in web editor, you don't get the terminal. Does anyone know why? Well, Mike does, but we're gonna ignore Mike. The reason for not getting a terminal is because this younger brother of Codespaces versus Codespaces already tells you what Codespaces is. Codespaces under the hood is not a web editor. Codespaces is a full-blown IDE with a working machine somewhere in the cloud that gets extensions installed, gives you a terminal, gives you access to Bash, gives you access to everything you have. So effectively, when I work with Codespaces, I usually do it because I don't want to install messy things on a computer I don't trust or which is not mine. I'd rather just open a VS Code, connect to Codespaces from VS Code, and effectively emulate whatever that machine in the cloud does on this brand new machine without having ever to install anything on the machine except for VS Code. That's what I appreciate about Codespaces. So if I say here, continue to Codespaces, and I create this Codespaces thing, it's still going to be in the browser, but I can at any point in time decide that I'm going to go to VS Code and use VS Code instead. And what I do appreciate about this repo, which on all fairness, I've actually forked from Donovan Brown, is that, let's zoom in again. We're getting our Codespace initialized, and it's building a container, because I told you, it's like a full-blown workstation. Well, it's a container, but and it is running on Kubernetes under the hood for sure. It's still building things. I don't know, but it feels like the Microsoft individual from here wants to leave and Codespace isn't loading up. Is this related? Like you almost leaving and Codespace is not loading? It usually goes a bit faster. We can blame the internet and Mike. But jokes aside, what I was about to show you was Codespace is loading up. Any moment now, I can view the logs. What did they say about those production VMs and gods? Yeah, it's one of those moments, isn't it, when you need to update your Kubernetes cluster. Still building. This usually goes blazingly fast, but anyways, there are some cool things in that web editor, like these workspace files. If you're running on a proper Codespaces implementation, actually, oh no, even in web editor, I can just click on one of these, and it changes the entire appearance. I can even change the theme if I want, and even the documents I'm looking at, to only look at the single microservice. And when I'm working with Dapr, I appreciate these JSON files, which are workspaces, because I can focus on a single project. I can focus on a single solution and effectively say, hey, I want to work with this project now. And then I'm switching over, swapping context to another project, but just by using a single JSON file. And it's not only the fact that I'm changing the file system, but I can also change the extensions I use. So if one of these microservices is written in Go, I probably want to have a Go extension loaded up in code spaces or VS Code. If I want to work with another project with another language, I probably want to have a different set of extensions installed, and so on and so forth. So that workspaces files are really, really, really powerful. I will try to head back here, and here's what one of those workspace JSON files looks like. So I have all of the words which I'm going to alias. I will have the files which should be included or excluded from my path, the folders and the path I'm looking into, and I also have everything else. Cool. Any questions so far? Yeah? No? Hugs and kisses, man. Is it inappropriate? We're just gonna hug. Yeah. Hugging with the Transylvanian.
Yeah,
You too, you too. For reference, I'm coming from Transylvania, so hence the question regarding the bite marks. I did get my fangs polished. Vampire jokes on me. So here I have, for instance, a couple of Dapr-based applications. Here is a Dapr albums application available on that GitHub repo I showed you previously, and a bunch more are available. These are already running. But the cool thing here is that, as you can see, I have a single environment. Think of this as like the plan of things. And then I have two applications running, the API and the viewer application. And what I do appreciate, and this is actually there's a Swedish company, a customer of mine that I'm working with, where we are creating one single environment, and then we're sharing this against with many different teams, pizza-sized teams, 5 to 7 people usually, and they all have their own API and their own application to work with. And within such an environment, you can already hook up your existing virtual network, which is shared with AKS. So effectively, you can make our AKS microservices extend over to ACA, and we can work on ACA apps to effectively offload whatever has been developed back in the day in containers and target to run in containers on AKS. So easily, on the next 3 years, the mission is to decommission AKS because of the experience that they've had so far in favor of Azure Container Apps. And this is something that has been going fantastically well over the past 8 months, imagine it or not. So as an operator, imagine I'm the operator guy, right? I am responsible for the environment. So if at some point in time I'm going to tell my colleagues, my developers that, hey, I can offer you some data storage. I'm just gonna hook it up over here. I'm gonna give it the name, and for each name I'm providing here, I will specify when the Azure Container App is going to be created, if it will have access or not, like authorization effectively, to this particular component, which can be a pub sub, can be a state store, can be an actor. Don't even get me started on actors because I'm so passionate about that. Secrets, for instance. And as an operator, I can specify what technology I'm going to use under the hood. I'm not, as an operator, I don't expect operators to be great at writing code. But then again, the advantage here is that as a developer, if I ever write an API, I can just, well, sign it off, have it running, and forget about it for a long period of time because of the lack of NuGet packages and integration I have, tight integration with the rest of the code. And it's really up to the operator to decide, hey, do we want to have new network security groups implemented or application security groups or whatever else in Azure to make sure that we have some sort of a firewall, security, whatever, boundary. He can or she can do that without the developer ever being involved, without changing a single line of code. Remember, there's no service invocation, there's no service discovery whatsoever. So this was the environment. When I look into the API, for instance, and the API would have to work with that component, the API, which is something that I would even RBAC my developers to, they can be contributors of these. They only specify or say, hey, here's the application ID and here's the application port that I'm going to communicate. And by the way, Azure Container Apps, again, they're fully Dapr enabled, meaning that Dapr is already running in these Azure Container Apps. In the case of AKS, Dapr would run as a sidecar. I don't have to worry about any of that nonsense. Sidecar, when you say sidecar to me, I just screams Kubernetes. I don't have to worry about any of that nonsense here. I'm just focusing on my own code. And then I specify, do I want to use HTTP or gRPC as a protocol for that communication? And do I want to have any API logging? And that's effectively it, right? Do you want to hook up an ingress? This is literally the only Kubernetes specific word that surfaces in ACA, ingress. But no other Kubernetes terminology will ever be shown in the Azure portal for Azure Container Apps. And under ingress, you're going to specify if you want to enable it and what type of an ingress you want and what transport protocol you're going to use, and that's it. But if you simply design a typical old school HTTP application, a web app or whatnot, you could hook up your custom domains here. And you could just say, I want to have an SSI SSL binding or whatever else on, say, a custom domain such as alexmang.dev. And then it would automatically handle all of this for me. Of course, I would have to DNS validate this one. What does my spelling checker ask for a correction on my name? That's wrong. And once it's validated, I just have custom domain. Isn't this experience super similar to the app services custom domain? It's very much similar, right? Imagine now that you have a new version of an API. The last thing you want is to take down your existing API. You want to run the new version alongside for a while, and once you have fully validated that it is running, then you're going to take your production code, which is targeting latest, to the new code, but anything else which is still targeting an older version because of backwards compatibility and whatnot can run as its own container app revision, right? They don't need to create a new app for that. And that's another cool part. So sure enough, in Azure Container Apps, there is this concept of revision management. And then I look into this one, I'll effectively say that I'm going to create a new revision. I'll specify what suffix, if any, I want. And then I'm going to specify what container image I'm going to utilize. And every new container image, like any new tag on a container image, or label, sorry, is going to actually update my Azure Container App to contain a new revision. And then once I have multiple revisions, and you'd specify here your registry and where you're pulling your image from and yada, 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 you could effectively say that you're doing traffic splitting, whatever that is. Oh, over here. So if you have multiple revisions, this text box here is no longer going to be grayed out, but you're going to specify how much traffic you want to give to it. And at any point in time, I can also choose to deactivate one of these revisions, meaning that it's an old version. Let's stop it and let's just see who comes screaming that their API dependency is no longer working, right? You can also do that. And it doesn't stop here. Like scaling, very similar to app services auto scalability or auto scaling rules. You can decide that you want to have multiple instances, but then you can also decide that you will scale not as a fixed number, but based on a rule. So you're going to add this rule. The UI is not as sexy as the one that you have in app services yet. But here I can just type in Alex awesome rule, and then specify that your rule is going to be based on an HTTP scaling metric or an Azure Queue metric or any other custom metric. Like you want to scale based on the CPU consumption, you can do that. You want to scale on the number of HTTP messages requests in the queue, you can do that. You want to scale based on the number of messages, brokered messages in an Azure Service Bus queue or an Azure Storage queue, you can do that. Those two options, the latter ones, are already available here on the HTTP scaling and Azure Queue respectively, but you can use any other metric possible. And the way this works is that you will have to specify a secret reference, which is going to be stored inside your Azure Container App, which is effectively kind of the connection string of sorts where you're looking into those metrics and you're pulling the metrics from. So it is a bit more, I wouldn't use advanced as a word, but it does have you type in more things, which can be quite abstract at the beginning without having documentation. Obviously, thankfully, there is documentation. It's not as sexy on the UI side of things yet. It's still a new product, but they're definitely working heavily on it, and you're going to see even more UX improvements there. Yes, that's it. You don't even want to work in the portal. You're going to do most of the things anyway through automation and IAC, and you're going to forget about them, right? So this is nice that you can surface it here, and it's going to be better looking at some point. But again, automation, automation, automation. Even Sam mentioned that the other day. And then you see a lot of interesting things which are, again, very similar to app services, but this has nothing to do with app services. It's only that experience that I'm telling you about as an analogy, like metrics and logs, obviously from the workspaces, log streaming, a very typical app services thing. The console, very typical app services thing. But this is a different console. This is a different approach because it actually gives you the standard output and the standard error generated by the container image. Alerting, obviously, almost every Azure service has that these days. So you pretty much get the idea here. 100%. One thing to point out here is that Dapr also has its own secret management capability. But the Dapr secrets management abstraction is not something that ACA does. So the secrets management thing is implemented differently in ACA. So what you do here is that you specify the secrets, and then you don't use Dapr for handling secrets. Because normally, in a Dapr specific application, I would invoke the Dapr on its port, and then do something like whack secrets, whack specify the secret, and I would pull the value from there. Over here, I handle the secrets and then effectively get them, I believe, through environment variables. Jakob, how do you pull the secrets in an application running in ACA? I think it's through environment variables, isn't it? Yeah. So there you go. So in ACA, there's no other way. This is the way. This is the way. Yeah. Oh, the ones that have app services where you specify a square. Not yet. Not yet. App services has indeed a middleware for reference for everybody, where you're using like square brackets and they say key or key vault, and then in parentheses you specify the URL and effectively the value that you want to retrieve, which would be a secret, like a generic secret, and then that actually the value of that gets injected inside as an environment variable, so you don't have to actually persist username and passwords for retrieving the data from key vault itself, and you do that through a managed identity, which is pretty awesome. We don't have that yet. Like, yeah, plain text. You actually can have the key vault integration with Dapr. Yes, you could actually retrieve that, but you would be missing the managed entity part. So there is indeed some maturity requirement yet. It's a brand new product. Remember that. Not everything is as polished as it could be. It's gonna get there. And once they're stored, by the way, you have no idea what I just typed in, right? Do you? Once they're stored, you're not able to retrieve them either. I have no idea what to say, but I'm gonna go with never. Let's imagine this would have worked. I told you, demo gods. Denied. Cool. I honestly don't know how much time I've left. Yeah? Cool. If anyone has any questions, I'll be happy to take them. Those 90 minutes. Yeah, go ahead. So, yeah. Yeah. Right. Right. So, so one thing that I completely forgot is when you ask questions, you're not allowed to ask hard questions. Jokes aside, I will paraphrase for the purpose of the recording, and correct me if I'm wrong when I paraphrase. Long story short, what you're asking is that when I'm working within my organization, there's a bunch of people doing a bunch of APIs, like the Ketchup API, the Mustard API. I have no idea about them. How can I learn more about them, especially if they put them in an AKS or in an Azure Container Apps or somewhere else, so they get surfaced in a catalog of things and I can utilize them, right? Would that be accurate? So that is that is a valid problem that we have had for so many years. And I would say that regretfully, none of the new technologies that we're seeing today are actually touching on this particular problem per se. So every company that I've ever worked with come up with their own solutions. Some of them, they create an API management, which is a brand completely different service, right? Fantastic service where they're surfacing these and they're creating these so-called products for the internal developers to have access to these APIs to use internally. And if they actually leverage API management, what they do next is that they have another product for their actual subscriptions for the actual applications that they utilize. But API management has a fantastic capability where for the developer portal, because they have a developer portal and then they have their APIs and whatnot, they allow you to test the APIs and even give you sample codes, and they give you sample curl request that you can do as an HTTP request, and they show you the actual output of that request and whatnot. So that's one approach that I would go with, and I find that this is a lot about the discovery and the learning experience. But if we go straight on to telling our developers how to write Dapr, because I kind of fished that there was another question that okay, yeah, yeah, right. It sure is. Yeah. Yeah, so long story short, the question is how do you enlighten, how do you make everyone available of the fact that we have a bunch of APIs that you can use? I believe strong that API management is the right product at this point in time to offer that. I would still, and honestly, since I'm not working for Microsoft, I can just say anything, right? But I will not say really anything. I will say this, however, I've already provided feedback when it comes to Azure Container Apps that it would be amazing to see some sort of an integration where they integrate this with API management to the extent where it automatically pulls the information available, right? Right now in API management, I can provide them an open API, aka Swagger file, which is a JSON that tells all the definitions possible with all the endpoints, with the HTTP verbs, with the payloads accepted, the payloads returned, and whatnot. And that is fantastic for me as a developer because internal or external, I can discover new APIs without having to go through sample documentations and GitHub material and whatnot from somebody who might have used it in the past, right? So it's pretty much like documentation for developers. We don't have that kind of service and integration as of right now, but I would not be surprised. I can only speculate, but I would not be surprised if that ever happens because when it comes to microservices, in all due respect, microservices lend themselves nicely for APIs, simply put. And for everything else, UI and whatnot, Stacy's Azure Static Web App presentation today did a fantastic job actually highlighting the fact, number one, that you want to use somebody else's computer to process the UI. You don't want to use your own uh, hardware for that. Yeah. Cool. So this was pretty much it. I don't know about you, but hopefully you got the idea uh, about what's so special on these applications. I believe strongly that when it comes to distributed applications, you do get resiliency and availability and continuity and a bunch of the other ETs that microservices and the cloud has to offer. And I also believe strongly that Dapr is that kind of technology. It's a runtime. It's not a framework. It's not opinionated. You can pick whatever language you want. You can run on any operating system you choose. It can be across multiple clouds. It can be across multiple regions in the same cloud. Doesn't matter. You can have applications which have APIs literally around the globe. It's not locking you in. And even more so, it's not AKS only or Kubernetes only. You can run it on your own machine. You can run it in Azure Container Apps. And by the way, Diagrid, the founding that they've got, the Diagrid company I told you about from Mark Fussell and Jaron Schneider, that is actually for a product which is very similar to Azure Container Apps, believe it or not, which handles the all underlying computing and hosting of your applications, which are microservices-based apps. And under the hood, they're using Azure, but they're handling things slightly differently. So the only question which remains really is if you guys are ready to get started with Dapper and create what I believe will be the next automobile-like revolution. And with that being said, enjoy the next upcoming last session. Actually, right? Is oh Fika. Oh yeah, Fika. They're very kind. They're very kind. Yeah, but that was it.